right, now we're looking at 2.3, linear functions and slope. What we're going to do is we're going to differentiate between the various attributes of linear functions. So remember slope, that's the ratio of the vertical change to the horizontal change. That's why it's a fraction, because it's a ratio. And here's your lovely slope formula. If you're given 2 points, x1, y1, x2, y2, the vertical change is the top, y2 minus y1. The horizontal change is the bottom, x2 minus x1. And it's a ratio, that's why there's a top and bottom. So we're going to practice with the slope formula. So we have x1, y1, x2, y2. Slope formula says we're going to take y2 minus y1 over x2 minus x1. So we are going to take y2 is 3 minus y1 is negative 7. And I'm going to do x2, which is negative 4 minus 3. I'm going to simplify that. 3 minus negative 7, that's like 3 plus 7, which is 10. Negative 4 minus 3 is negative 7. So our slope is negative 10 sevenths. All right, let's try another one. So we're going to take for our slope y2 minus y1. So y2 minus y1, so negative 9 minus negative 9 over x2 minus x1, so negative 6 minus 2. Negative 9 plus 9 is 0. Negative 6 minus 2 is negative 8, so our slope is 0. And we know that because this one happens to be a horizontal line. Both of the y values are at negative 9. Let's try another. We take y2 minus y1, so negative 8 minus 4, over x2 minus x1, 5 minus 5. Get negative 12 over 0. That's undefined because you cannot define or divide by 0. That means this was a vertical line, and it is true because both the x values were at 5. So remember our first one was at negative 10 sevenths. That's a negative slope, so it goes decreasing. The second one was 0, so his function is going to be flat horizontal line. And our last one, negative 12 over 0, was undefined, so he's a vertical line. Remember, a positive slope is rising or increasing from left to right. So it looks like this. Negative slope is going to be falling from left to right. A 0 slope is a horizontal line, so he's flat. And a undefined slope is a vertical line, so it's straight up and down. Slope-intercept form, that's the one you know, y equals mx plus b, where b is the y-intercept and m is the slope of your line. Point slope formula is if you're given a couple of points, then you can find the slope, or if you have a known slope, you use it. This is the slope m, and then your points are x1, y1. You just choose one of the points to plug in for that. So there's the point slope formula, which if you notice, this part here, the x minus x1, is like the denominator of the slope formula. All we did was move it over. It's kind of a cool idea there. So I'm going to erase that though, because I don't want to confuse you. So now we're going to find the equation of a line. They want it in slope-intercept form, which we know is y equals mx plus b. And they've told us the slope, which is m, and they've told us the point, x1, y1. Well, this is not a b, it's a point, so I'm going to have to use point slope formula, which is y minus y1 equals mx minus x1. I'm going to plug everybody in. So y minus, there's y1 equals m, that's the slope, x minus x1. And then I've got to simplify that and put it in slope-intercept form. So I have y minus 2 equals 4 times x minus a negative is like plus 6. Then I'm going to distribute over here. So y minus 2 equals 4 times x is 4x. 4 times 6 is 24. Still don't have it solved for y, so I got to move the 2 over. What you do to one side, you do to the other. So I get y equals 4x, and 24 plus 2 makes 26. There's the equation of my line in slope-intercept form. So I can look at that and tell the slope is 4 and that the y-intercept is at positive 26. Now, do you remember how to sketch a line? Remember, you always start with the y-intercept and then you use the slope to go up and over or whatever to get your second point, and then connect the dots. So we are going to sketch this line. And here's my axis. So I start with the y-intercept. Y-intercept is at positive 1. And then I'm going to use the slope. The slope is negative 2 over 3. So that means I'm going to go from that point down 2 and right 3. So from the red dot at y-intercept, I'm going to go down 2 spaces and to the right 3. And then I'm going to connect the dots with a nice, beautiful line. And since this is a negative slope, this thing better be decreasing from left to right. And again, what did I do? I went down 2, and I went to the right 3 from the y-intercept, and then connected the dots. There's a picture of him. We plotted 0, 1. There's 0, 1. And then we went down 2 boxes over 3, right there, connected the dots, and there's our beautiful line. Intercepts. Remember, the x-intercept is the point where your graph intersects the x-axis. The y-intercept is the point where your graph intersects the y-axis. So without looking at a graph, we're going to find those. Here's my equation up here. And if you think about it, the x-axis, that is the horizontal line, the axis. That's when y is 0. And then the other one, the y-axis, that goes up and down in the middle, that one is when x is 0. So we're going to plug in 0 for the opposite variable or letter, and we'll get the intercepts. That's the old school way to do this. So if I want the x-intercept, I'm going to plug in 0 for all the y's. So I'm going to write 2x minus 3 times 0 for y. Well, that's 2x. 3 times 0 is 0. And I'm going to solve for x, divide by 2 on both sides. And I get the x-intercept is at 3, 0. And that makes sense. He's on the x-axis. Now I'm going to do that for the y-intercept. The y-intercept is on the y-axis. That's when x is 0. So I'm going to plug in 0 for x. So 2 times 0 minus 3 times y equals 6. 2 times 0 is 0. So I get minus 3y equals 6. Solve for y. So y equals 6 divided by negative 3 is negative 2. So the y-intercept is over at 0, negative 2. So the idea on x and y-intercepts is plug in 0 for the opposite letter